Hello and welcome to the first page of your EOC packet. The first question says, what are the factors of 10x squared plus 4? Remember that with factors, we need to think numbers that are multiplied together. Okay, and the 4 doesn't have anything being multiplied by him, so the 4 is not a factor. What we do have is this 10x squared. And remember, we can break that apart. And what this really means is 10 times x squared. So our factors are actually 10 and x squared. If we were looking at terms, I want to remind you that terms are separated by a plus or minus. So our terms would be 10x squared, comma 4. Our constants are numbers that are by themselves with no variable. That would be 4. And our coefficients would be the numbers in front of variables. So that would be 10. So just a reminder of some vocabulary that we learned at the beginning of the year. Number 2 is a dimensional analysis problem. And it says, Kayla wants to drink 26 pints of water a week. How many gallons is this? So again, we can set up a long chain of fractions to convert pints into gallons. So we'll start with 26 pints over 1, and we're going to set up a fraction. And I have a conversion that says that there are 2 pints in 1 quart. So I need to put pints on the bottom so that it can cancel with the pints on top. 2 pints, 1 quart. And I have another conversion that says that 4 quarts equal 1 gallon. So again, I can say the pints cancel, the quarts cancel, and I'm left with the unit gallons, which is what I want. And of course, this is 26 divided by 2 divided by 4. And what we end up with is 3.25 gallons. Let's see, that's answer C. Number 3 is another dimensional analysis problem. We need to compare Joe to Bob, but we can't compare them yet because Joe is in feet and Bob is in meters. Well, we can take Bob's feet, 5.3 feet, and convert it to meters. We know we need feet on the bottom and meters on top so that the feet will cancel. And our conversion happens to be 0.305 meters to 1 foot. So in this case, our feet cancel and we're left with meters. And we take this times 5.3 times 0.305, and there's our 1.62. So we know that Joe is 1.62 meters. If we compare it to Bob, we know that Bob is taller. So that's the long way to get that answer, but I want you to think about this because I didn't really have to do any work on number 3. I should automatically have a clue that a meter is almost a yard, and there is no way that Joe or Bob is anywhere close to 17 meters tall. I should be able to X those out automatically. Secondly, both of these have the same answer here for Joe's height. And I should be able to just check back in with Bob, see that he's 107 or 1.7 versus 1.6, and know that Bob is the taller one. So don't do too much work when you can look at your answer choices and get the correct one. Okay, so number 4 says, what unit should the following be reported? The cost of renting a car. Dollars per day is your correct answer here. Okay, moving on to number 5. Number 5 and 6 match the problem with the correct classification in the box. Remember that linear are in the form of y equals mx plus b, which means that your x is going to have a coefficient on it, or it's just going to be an x. And exponential, so that's linear. An exponential means that the x is not located in the equation there, but rather in the exponent. So you got a little bitty x if it's exponential. Expression is no equal sign or inequality signs. Equation means, of course, just equals, and inequality means any of these signs. So number 5 would be a linear inequality, and number 6 would be an exponential inequality. Number 7 says, write the expression for the following scenario. The sum of a number squared and 13. So when we see the word sum, we should automatically think addition, so we can mark out C and D right away. So the difference between this is x squared plus 13 and 2x plus 13. Notice that it says a number squared, so that means we've got an exponent on it, and the correct answer is A. The correct wording for B would be twice a number, because we have had that, the sum of twice a number and 13. So the correct answer is A on number 7. Okay, number 8 is the discount problem, and we always have problems with the discount problem. The standard way is to say the cost minus the discount times the cost again. And whatever we put here for cost, we copy and paste here for cost. So it says X is the cost of one shirt. So of course she bought 4. So the cost is going to be 4 times X, or 4X. And of course, that's going to go in my parentheses as well. And I've got to include minus the discount. So it's going to be a minus. Got a 35% discount, which means I need to change it to a decimal. And what I end up with is 4x minus 0.35 times 4x. Now I'm going to do a little PEMDAS. I'm going to multiply first, so that I have 4x minus 0.35 times 4, 1.4. And of course there's an x in this. And now we can add these two terms together. And we end up 4 minus 1.4 is 2.6x. 2.6x. Okay, let's take a look at number 9. Number 9 is, we've done a lot of these problems in the past. The sum of 3 consecutive numbers is 123. So consecutive numbers, remember, are ones that come right after another. So 4, 5, 6 are consecutive, 17, 18, 19 are consecutive, but we don't have any idea where we're going to start. So we're going to give the first number, call it x. The only thing we know about the second number is that it's going to be 1 more than the first number, and the only thing that we know about the third number is that it's going to be 2 more than the first number. So now we have x, x plus 1, and x plus 2. We're going to add all of those together because it does say the sum of. So x plus 1 plus x plus 2, and that is, or equals, 123. And now we're going to simplify. We'll combine our x terms. X plus x plus x is 3x. 1 plus 2 is 3. And now we've simplified our equation. And our answer here is A. Okay, which of the following scenarios can be represented by the equation y equals 5x plus 50? I want you to remember this is in the form of y equals mx plus b, where m is our slope, and another word for slope, remember, is rate of change. So our rate of change here is going to be 5. We're changing by 5. B is our y-intercept. And often when we talk about word problems, this is our starting value. So when we read through this problem, let's just remember that m is our rate of change, which in this case is 5, and our b, our starting value, is 50. So Andrea made 50 cookies for a fundraiser, and 5 cookies were eaten every hour. Well, if we were eating cookies, we would be subtracting 5, so that doesn't look like a good idea. Bailey spends $5 on lunch and $50 for each pair of jeans she buys at the mall. So it sounds like Bailey's spending $5 one time and $50 several times. That doesn't make sense. Casey has $50 saved for a dirt bike and saves $5 more each week. Absolutely, that choice is going to be good. We have a starting value of $50, and we're going to add $5 every week. That's our rate of change. Okay, for number 11, the equation y equals 3 times 2 to the x can be used to represent the rate at which the fish population is increasing in a pond every day. So let's remember what we know about exponential equations. Remember that a is always our starting value, or maybe initial value. B is the rate that we're going to multiply by, and of course x is our time. And we see that in this case 3 is our starting value and our rate is 2. So the fish population is doubling every day. That looks correct. We're not tripling, we're actually starting with 3. We're not increasing by 2 every day because that implies that we're adding 2 every day. And this implies that we are subtracting 3 every day. And of course, exponential, we don't add and subtract, we multiply. So the correct answer here is A. Okay, number 12 is talking about inequalities, and the easiest way to solve these is to just plug in the point for x and y and see if you make a true statement. So I'm going to plug in -4 for y, less than, plug in 5 for x. What I end up here is 4 is less than, or -4 is less than -4. That's not a true statement. So I'm going to move over here and try again. -4 greater than or equal to -3 times 5 plus 5. So what I have here is -4 is greater than or equal to -10. And of course we know that that is a correct answer. Okay, just to be safe, let's go ahead and test the other ones and see if there's multiple correct answers. We have y, which would be -4. -4 is not greater than 6, so that is false. And plugging in -4 for y and 5 for x again. Well, this is going to say -4 is greater than or equal to, I don't know, something huge here. What is that, 41? Definitely not true. So correct answer is only B in this case. Moving on to number 13. This one says, Lacasia brings $40 to the mall to buy some more fingernail polish, X, and bracelets, Y. Each polish is $3 and each bracelet is $8. This situation can be represented by the inequality 3x plus 8y is less than 40. Is Lacasia able to buy 4 polishes and 3 bracelets at the mall? Well, let's just plug it in and see. She has 4 polishes. Remember that polishes are x, so we'll plug in 3 times 4. and she has 3 bracelets. Remember, that's y, so that's 8 times 3. And let's see if we make a true statement here. When we simplify, we end up with 12 plus 24 is less than or equal to 40, and then 36 is less than or equal to 40. So she's going to have $36, and she has how many dollars left over? $4. So yes, she can buy what she wants, and she has $4 left over. Okay. Number 14 is another inequality problem. Or I'm sorry, it's not. This is an equation because we have an equal sign there. So what I want you to remember about solving equations is that we have our order of operations. First thing we're going to do is parentheses. So I'm going to do the distributive property. So the distributive property means I'm going to multiply 3 times x and 3 times 2 to get 3x plus 6. And then I have minus 6x equals 12. So that was our distributive property. Next thing, we need to combine like terms that are on the same side of the equal sign. And remember, when we combine like terms and they're on the same side of the equal sign, we're simply going to say 3 minus 6. 3 minus 6 is negative 3, so that gives us negative 3x, and then of course we have this plus 6 equals 12. Now we're ready to get the constants together by themselves. We'll subtract 6 from both sides so that we have negative 3x equals 6. And then we'll divide by negative 3 on both sides, and we get x equals negative 2. So the answer here is going to be B. Okay, number 15 is solving an equation, but this time we're solving an exponential equation. So remember, if we're solving an exponential equation, our first step is to get everything to the same base. And remember, our base is this big number here. So we're looking at 1 over 25. The first thing that I'm going to do is I'm going to write 25 to the negative 1. Because if I want to get rid of a fraction, remember that's going to give me a negative 1. 25 to the negative 1 exponent. Now, I want to see, can I write 25 as a base of 5? Of course I can, because 25 is the same thing as 5 squared. Now remember, I'm going to need to multiply these two exponents together. So when I multiply this 2 and this negative 1, I end up with 5 to the negative 2. And you may do that in a shortcut, do that all in one step, and that's totally fine. Now, once we have the bases the same, they're both 5, we can set the exponents equal to each other and just solve from there. So we end up with x equals negative 6. And our answer then is D. Okay, moving on to number 16. Number 16 says solve for the variable h. So what we have is v equals pi r squared h. This is called a literal equation because it has more than one variable. And our goal is to get everything except the h on one side of the equal sign. So these are multiplied by the h, pi times r squared times h. So what we're going to end up doing is dividing by everything that's not an h. We're going to divide both sides by the pi and the r squared. And of course on this side they cancel and leave us with nothing but the h. And over here, there's nothing I can do to simplify that, so I'm simply going to leave it as v over pi r squared. And there's my answer, number B. Okay, so number 17 says solve the system of equations. Remember that we can use substitution or elimination based on which one looks like it's going to be easiest for us. Elimination. In this case, I'm going to choose elimination because they're both in standard form. If I had one set equal, solved for x or for y, I might use substitution. But again, my whole goal is to eliminate either the x's or the y's. So I'm just going to say, for now, I think I'm going to try to eliminate the x's. So I need to get them to be the same coefficient but opposite signs, which means I need to multiply the top one, and I need to multiply it by 2 because that's going to give me a 6x. But I can't just multiply the first term by 2, I have to multiply everything by 2. So that would give me 6x plus 4y equals 12. Whoops. And of course I'm just going to write down the next one. No changes to the second equation. And then we're going to combine them. Those cancel out, these cancel out, and these cancel out, and leave us with 0 equals 0. Remember, if we write a true statement at the end, we eliminate both variables. That means we're going to have a special case. And when we say true, that we have a true statement, that means we're going to have infinitely many solutions. If we had gotten something that ended up like 0 equals 5, and we had a false statement at the end, then we would say no solution. But again, that's not the case for us. We have infinitely many solutions because we made a true statement. Okay, number 18. Which of these graphs correctly shows the solutions to these two different linear equations, and what is the solution? Well, the first thing that we have to do is get both of these in the form of y equals mx plus b. So for this second equation here, I've got to subtract 2x from both sides, and that leaves me with y equals negative 2x plus 9. Now the easiest thing for me when I'm going to pick out a graph is I'm going to say, okay, let me look at the y-intercept. I need a y-intercept of 4, and I need a y-intercept of 9. Can I eliminate any of these graphs? It doesn't look like I can. Looks like the y-intercepts are both 4 and 9 on both of these graphs. Okay, so now what I'm going to look at is I've got one negative slope and then two negative slopes, negative 1/3 and negative 2. Are both of these negative slopes? Well, I can eliminate A because this line right here, this blue line, is a positive slope, and that doesn't work with either of my choices. Now I'm going to look at slopes. I've got a negative 2 slope with my one that crosses at 9, negative 2. Okay, so I do agree that my red line is the y equals negative 2 plus 9 because I do have a negative 2 slope. And that happens to be the same over here. So that is a slope of negative 2. Now we've just got to figure out which one has a slope of negative 1/3. Let's see, this one goes down 3 over 1, so this has a slope of negative 3. So we can X that out. So this is our slope of negative down 1 over 3, which is a slope of negative 1/3. So it says the solution is 3, 3. Well, obviously, the solution is the point of intersection, and that is true. The second way for us to do this would be to look at these solutions. If I wanted to confirm that 3, 3 was in fact a solution, I would just go plug it back into the original answer. So I would say 3 equals negative 1/3 times 3 plus 4, and I would see if I made a true statement. Well, that's 3 equals negative 1 plus 4, which is, yes, 3 equals 3. So that 3 does work in that first equation. Then I would go and plug it into the next one. 2 times 3 plus 3 equals 9. Well, yes, 6 plus 3 equals 9, and then 9 equals 9. That is a true statement as well. So we know that the 0.33 works in both of these. So if you prefer to plug in these solutions to find out which one is correct versus looking at the graph and trying to identify which one has the correct slope and y-intercept, that's an option as well. Okay, so this one says write a system that could be used to solve this, and you can see that we have the answer B here, but let's talk about why that is. Virginia's buying nail polish, which is $4 per bottle, and nail files, which is $2 per box. She bought a total of 80 items and spent $200. So typically when we write these equations for systems of equations, we have one that's talking about the total cost and one that's talking about the total items. The total cost is going to have to do with this $2 per box of nail files and $4 per bottle of nail polish. And the cost, of course, the total cost is $200. So we need to see an equation that's got a 4 and a 2 in it along with the $200, which means that we can X out this one because it has a 4 and a 2 and an 80, so that's not right. And same thing with this one, so that's not right. So we know both of these equations are the same. It's either going to be A or B, and then we're just going to plug in and see what works. 60 and 20 both plug in here to equal 80. Let's see if we can plug it into the top equation and have it work. 4 times 60 plus 2 times 20. And remember, the 60 has to go with the $4. The 60 has to go with the $4 nail polish, and the 20 has to go with the $2 nail files. And let's see, that's $240 plus $40, which equals $280. So that is not a true statement. That does not equal 200. So therefore, B must be the correct answer. Okay, so number 20 is another inequality. And remember that our whole thing is if we have a closed circle, that means we're going to translate that into square brackets, or we're going to translate that into an equal sign on our inequalities. If we have an open bracket, then that means that we are going to translate that to parentheses and just regular inequality, strictly less than or strictly greater than. In this case, we have a closed circle on the 2, an open circle on the 5, so we need to look for a square bracket on the -2 and a parenthesis on the 5, and that would give us our answer of A. I hope this video has been helpful. If you have any additional questions, please ask your Cole teacher.